Okay, good morning. We're going to run the antique motor on a mere 12 volts. And then after this test, we'll run it on a lower voltage yet. Here's a small battery, a gel lead acid battery, and the wires are connected to the motor. So, and if I zoom out, there you can see the switch at the top of the motor. When I rotate the switch, oh, and by the way, I'm using stereo mics. This is a tiny lapel mic, so it's right up there next to the motor, so you can hear the motor run. Once I start this running, I'm going to take the other lapel mic from my collar and clip it to the motor. You see how smooth it starts just by itself on 12 volts. It runs just silently. Pardon the microphone noise. I'm going to now put this here. Here, we'll get it spaced here. Here, pardon that microphone movement noise. So those are omnidirectional mics. They're picking up all the sounds of outdoors. When it's quiet, you should be able to hear the motor. Let's see if we can zoom in and get a closer view of things as they run at this speed. Now this motor will also run on 6 volts, so you can get a 6 volt gel cell battery. Let's pause the camera for a moment and try a different view. Okay, now we're running on 12 volts. Listen how quiet it is. Now I will just move the motor. The motor is sitting on a pad of cloth so it won't scratch the base. And we're just going to rotate the motor a bit about so you can see it in different positions, in different aspects. And those, like I said, those black things there, those are the microphones picking up the sound. Probably a lot of my sounds are being picked up too, moving the cord about. There's the back shaft. You see how long it is? Notice that it overhangs the neighbor's cutting wood. Notice that the shaft is so long that it overhangs the back of the base. That would be clearly so that you could put this to a work table and then screw a fan blade to it. I mean, this is not only the first appliance motor, this was their first version, optional, of the electric desk fan, the first electric desk fan. Although this was never used as a desk fan, nothing was ever mounted on it because there's no screw mark on this shaft. It has a D flat on it. As I said in the text, the bearings have no wear. The oil cups, just a little bit of synthetic oil wicks in automatically. When I got this motor many, many years ago, I merely cleaned it up with Gojo brand hand cleaner, white mechanics hand cleaner, not the gritty kind, the smooth, creamy white kind, not pumice. Use Q-tips and rags. It doesn't remove anything but dirt. So what you're seeing is original brass that was all varnished over. Some of that varnish has gone, it's turned brown, and some of it is flecked off, so the shinier portions are the brass. Okay, so we've been running it on 12 volts. I'm going to put the microphone right up to the commutator so you can hear the running sound. At this voltage, with no load on the motor, it could be run all day, every day, underneath a display case. It would cause it no harm. Just use synthetic motor oil of SAE 40 or 50 weight because it's running so slow. That thickness of oil is a good thing for it. And don't use too much oil. And as oil appears at the bearing journal outside, just wipe it off. Now, see, I'm going to stall it now. You cannot hurt the motor at this low power input. I'm just showing you that all the commutator bars, all the commutator windings are good. There are no dead spots. It is absolutely smooth rotation. Okay, here I am back again with a 3 amp lab power supply. These are not expensive to buy on eBay. And with this, you wouldn't need any battery. It makes a very pure DC voltage. Now, next up, I'm going to change to a, as I dial this up, I'm going to change from a battery to a power supply. It's adjustable from 0 to 30 volts. So let's see how it runs. So the next thing you see is going to be a yellow case. In other words, here we are at power supply used by electronics. About 6 volts. Let's zoom over to the motor. You can, I'm sorry about the camera movement, it's a shaky tripod and a shaky medium. Alright, you see it's just barely running. Let's zoom in a little closer if we can. I think that'll still be in focus. Or better yet, ouch, sorry. Let me bring this into camera view. I have to zoom out for it to be in focus. We're running on 6 volts at the moment. Now, if you were to display this, pardon the microphone noise, I'm moving the cord out of the way a bit. Let's get that commutator centered, because that's where all the action is, right? Let's bring the motor closer. I like close-ups. Let's see if we can get any closer. The camera lens is only a few inches from the motor now. There. It's drawing 3/4 of 1 amp at 7 volts, 6 volts. That's 6 volts. So you see, it doesn't take much of a battery to make this run, just to see it run. Let's cut the voltage down slowly and see how slowly we can make it run. I've never done this before. You can see here by that set screw rotating how slow it's running. Naturally too, because the brushes are made of brass and the commutator tarnishes, if the motor has been laid up for a long time, it won't run quite this well when you first start it. It has to run for a few minutes and wipe off the tarnish that has collected. We're at 4.5 volts. Let's turn it down a bit more. And then we'll do a high-speed run. We're at 3.5 volts. One-half ampere at 3.5 volts. You could run this off of two flashlight batteries and it would just tick over. Okay, let's turn up the voltage. We can go all the way up to 30 volts or 3 amps, whichever comes first. Now there's 8. Here's 10 volts. We're using 1 amp. Remember, this is a 110 volt DC motor. We're running it at 10% of its capacity practically right now. There's no harm and there's no wear. 15 volts, 3/4 of an amp. 20 volts. Now let's go to 30 volts.